Okay, this is Unit 3, Lesson 4. Tomorrow we have a quiz, second semester, 7th grade math. For the warm-up, vocabulary review, what is a sequence? Who can tell the class what is a sequence? Does anyone remember? Miranda, go ahead.
Is a set of numbers that follow a pattern.
Nice. It's a set of numbers that follow a pattern. Okay, moving along. All right, write an expression to describe each sequence. Okay, so I'm going to try to review a little bit of what we covered in Lesson 3 with the functions. So, number 2. Do we have a sequence? What kind of sequence do we have? Who can talk us through that? Charles? Uh-huh. Right. So, no. You said you keep adding 5. We had a name for that. If we add the same thing to each term to get the next term, shh. Now everybody wants to call out. I'm going to call on somebody that's raising their hand. Michaela, what is that? It's an arithmetic sequence, but what do we call the pattern that Charles identified from one term to the next? What do we call that? We're adding 5 each time. What do we call it? We had a name for that. And this is specific to arithmetic sequences. What do we call that? We add 5 every time. What is that?
Common difference.
Common difference. So here we had a common difference of add 5, to each term. Okay? So for my function, if I have a function and my variable is x, that would equal 5 times my variable x. But let me ask you something. For the first term, if I substitute 1 into my function, do I get back my y, the first term? What about the second term, 2? If I substitute 2 in there, does it work? So it does work, so we don't have to make any adjustments, right? Right? So because we don't have to make an adjustment, this is not only an arithmetic sequence, we can also say it's another type of sequence. What's the other sequence? It's a geometric, but if it's a geometric, that means it has to have a common what? Common ratio. And so what would the ratio be? What would the common ratio be? Yeah, we multiply each term by 5. So 1 times 5, 2 times 5, and so on. So it's also a geometric sequence. Because we have a common ratio. And that common ratio is times 5. Remember, 5 can be written as a fraction, 5 over 1. All right, so what about this next term over here? Or this next list of numbers, okay? What do we have?
Add 2 repeatedly.
Yes. Alexis says we're adding 2 repeatedly, okay? And so what type of sequence is that? If we're adding, can you help him out, Khadijah? It's an arithmetic sequence, and the add 2, what do we call that for an arithmetic sequence? See, it's the common difference. So Alexis is correct. We see that we add 2 for each term to get to the next term. It is also an arithmetic sequence. But this is a little different than the first one. So let's take a look at this. So we have an arithmetic sequence, but it's a little bit different. So let's take a look. I got a function. Okay. Now, for this function, my input is x, and then my common difference can be multiplied to x. Well, is this true? If I put in 1 into my function, do I get back -7? No. Can I fix it? How would I fix it? How would I fix this expression?
Subtract it by 9.
If we subtract by 9, it works, right?
Yes.
So guess what? This one's not geometric because we had to make that adjustment, -9. It is arithmetic. This one, this is geometric and arithmetic because I didn't have to make an adjustment there. Do you guys see that? Yes. So one's arithmetic, one's geometric. Now take a look at the next one. And let's see if we can see what's happening here based upon 2 and 3. Who can tell me what's going on here? Chin?
You're adding 101.
Very good. So we're adding 101 for each term. And then if we add 101 for each term, what's my function going to look like? What, you can tell me what's the sequence? It's an arithmetic sequence, but what's my function going to look like?
Good afternoon, CPA students and staff. This is just a friendly reminder. 8th grade, if you have not done so
101x.
you should be in 3rd period. 8th grade, if you have not done so, you should be in 3rd period.
Now, does this work for all my terms? Do I need to make an adjustment here? If I put in 1 for x, do I get back my first term?
Yeah.
Right, I do, right? So I don't have to fix this. So not only is this an arithmetic sequence, I heard it. It's also geometric because why? I can multiply by 101. 1 times 101, 2 times 101. So because I have a common ratio also, it is also a geometric sequence. Okay, and we're going to be talking more about that. So we talked about a geometric sequence, arithmetic sequence. If we have to make an adjustment like we did in number 3, it's only an arithmetic sequence. Now, over here, what we're doing today is we're going to start drawing some graphs. Do you guys know what a graphical designer does? They draw things. They can work for an advertising company, and they can set up, the advertisement. They're into like what you visually see, graphically. Okay, so if we want to graph a function, we're going to have a picture that goes with the function. Does that make sense? We're going to draw something, is what I'm trying to get to. So what you'll learn, to find solutions to application problems using tables, rules, and graphs. Why learn this? If you know your height in inches, you can find your height in feet. You can show the relationship between units such as inches and feet using a table, a rule, or a graph. A graph can show the relationship between inputs and outputs. Okay, graphing using a table. All right, so for this, we have a graph. Remember the horizontal axis is the inputs or the x values, and the vertical axis, the up and down axis, is the y, the outputs. You guys understand? Okay, now here's what they give us, graphing using a table. The table shows a relationship between the number of inches input and the number of feet output. The rule is the function for n equals n divided by 12. But let me rewrite this so it looks a little more familiar to you. And instead of n, I'm going to use x. Can I do that? I just rewrote it a little bit. Now, if you notice, is there add or subtract at the end of this expression? So think about what we learned in the warm-up. Is it geometric? Think about that. Is it arithmetic? Yep. Now, they throw you off here because, look, my inputs, they don't go for 1, 2, 3, 4. They skip. So it's not showing every single value you can enter. Okay? So this is called a linear function, and we're going to get to that here in a second. So let's go ahead and graph it. Now let me show you something. So for here, I'm going to graph, and I'm going to draw my ordered pair. That's a comma between them. Do you guys remember doing this earlier this year? Okay, so let me show you. So my input values for x is what I enter. That's going to be 12, 24, 36, and 48. And then my outputs are what I get back. I get 1, 2, 3, and 4. Now I'm going to graph all this on that number line. So over here, I want to take 12 and 1. So over here, I'm going to graph this in green. So 12 on the horizontal axis, I got to find 12 first. Here's 12 right here. And then I go up 1. So at 12, here we go. and that is 12, comma, 1. Do you see how we graph that?
Yep.
Okay, now I got to graph the next input-output, which is the x and the y, 24 and 2. So I find on the horizontal axis first, the first number, 24, and then I find 2 up, 24, comma, 2. Are we good? Okay, now for the next one, at 36 inches, my input, my y, my output is going to be 3. So at 36, I'm at 3 right here. So 36, comma, 3. There we go. And then the last one at 48, we're going to be 4 feet. So here's 48. I find 4, 48, my input, and my output was 4. Now, if I were to draw a line through all these points, I get a straight line. That's why it's called a linear function. Do you guys understand? And guess what? Because I don't have to add this, I don't have anything added to the end of this expression, this line goes through the origin 0, 0. Do you see that? At 0, I get back 0. Do you understand? Are we good? Now, because it goes through 0, 0, we saw that it can be a geometric and an arithmetic sequence. But if I were to add something, this line would stay the same. It would just go up, or it would just slide up or down. It would stay the same steepness, but it would go up a level. Does that make sense? So if I put +1, all these points would just go up 1. You guys understand? Okay, it'd still be parallel to this line. It would just be shifted upward. Okay, so let's take a look at some other examples. Question? Nope. Okay, take a look at this. Nope, periods are too short today. We're going to get through this. I need you guys to sketch this graph out. Here we go. Now, if you really want to show me that you've been paying attention, I would love to be able to see that you can give me the function too on top of the graph. But really all I need you to know how to do is graph this table for the inputs and outputs. Some of you that were paying attention to lesson 3 and what I covered so far, you can probably give me the function too. I'm looking around, and almost everybody has drawn this out. That's good. So tomorrow when you have to do this for a quiz, you'll feel more comfortable about it. If you're not yet participating, I need you to start participating. So I'm looking around. I can already see that some people have graphed these coordinates, and they got a straight line when they connected all those dots, right? So let's go ahead and go through this. But before we do, can I go ahead and come up with my function? So remember, a function is going to have a variable, and you might have to make some adjustments. Our variable is going to be x, and then we have our output, which is our y. Okay. All right, so let's see what we got here. So for our outputs, do we see that there's something going on there? What's happening? Jaden? We add 2 for each, right? So if we add 2, I know my coefficient in front of x, my number in front of x is just going to be +2. Okay, 2x. Now, does this work if I substitute 0 into for my input for x? Do I get back the right number? No. So I have to make an adjustment, right? What's the adjustment going to be? Got to add 3. Now, Because I add 3, is my line going to go through the origin? Is it going to go through 0, 0? No. So that means my outputs are what type of sequence only? They're just arithmetic. They're not geometric. Okay? If they go through the origin, they are both arithmetic and geometric. But because we had to make that adjustment, it's just arithmetic. So now let's go ahead and graph these. So remember, I have to graph 0, 3. The first number is x. The second number is y. 1, 5, 2, 7, and 3, and 9. And this is what I've noticed over the years is a lot of students won't even use, not a lot of students. There's a few students that don't write this down correctly. They'll forget to put the comma, or they won't use parentheses around it. You have to put parentheses around your set of numbers that they call an ordered set, an ordered pair. An order means there's an x and then a y. Do you guys understand why it's an ordered pair? You can't just put whatever order you want. It changes where the coordinates can be graphed. So let's take a look at this graph. And we're going to go ahead and put this in here. And so over here I got, for the first one, 0 and 3. Here we go. You see how I put it between 2 and 4, halfway? Okay, and then notice because it was 0, I didn't go left or right. I just stayed right here at 0, 0. Do you guys see that? And then 3, I went up 3 levels. Got it? Okay, so the y is like, what level am I on? The x is, where am I sideways? Do you guys understand? Okay, so for the next coordinate, I got to go sideways 1, and then I got to go up 5. Well, here we go. And that is 1, 5. And this one was 0, 3. Now I got to find 2, and I got to go up to 7. Here we are, 2 and 7. And then the last one, 3, I go sideways 3, and then I go up 9. Okay, and then when we drew a line through all this, what did it look like?
A straight line.
It was a straight line. Except for this one was a little bit different than the other one because this one doesn't go through the origin, right? Okay, it will never cross through 0, 0. Okay? So, any questions about that? Now, notice for every x I put in, I get a bigger and bigger y, right? That's called a positive relationship because my y has become larger. And notice what's in front of my x? A positive number. So if the number in front of my x was a negative, it would be a negative relationship and my line would be tilted downward. My y values would decrease as I go up in x values. So I'm trying to get you guys ready for what's coming eventually. Okay? Question?
But what if you basically put,
Like a horizontal line?
no, like -2, but still, but -3, would that still be?
Well, if I had a -3 here instead of a 3,
Yeah.
it would be a parallel line, but it would just be down. It would be a parallel line. Another line, it would just be parallel, and it would start at a lower point, right? Okay? Are we good? Okay, we'll see more of that later, but that's a good question. Okay, given a function rule, you can evaluate the function for any input value. Application, plants. A plant grows 1 38 centimeters for each hour of sunlight it receives. Write and graph a rule to find the growth of the plant when it receives 4 hours of sunlight. So now I need you guys to make your own function. From that information right there, make your own function. And then you need to make a table, and we're going to graph it.
The centimeters will be where?
Yep, how much did it grow? And the hours will be the x. Hours of sun would be your x. Can somebody tell me what my function is going to be? Who can tell me what my function is going to be? Can I get a volunteer? Raise your hand, I'll call on you. Khadijah, what do you got?
The function is x equals 1.38 centimeters x.
Yep, very good. So, all right. And we don't have to make an adjustment because at 0 hours of sunlight, there's not going to be any growth, right? so we don't have to adjust that, but that's my function. And so let me go ahead and graph this. Okay, any question how we got that function? We're good? All right, I'm going to go ahead and graph these values. So here we have, in 1 hour, we have 1 3800 inches. In 2 hours, we have 2 7600 centimeters, excuse me. And we got 4 1400s. Can somebody tell me what we get in 5 or in 4 hours? What do we have in 4 hours? Anybody get that? What? 5 and 5200s, correct. Okay, so now we're going to graph this, and this is where students kind of struggle a little bit, so I wanted to take some time to go over this with you. So look, my input is 1 hour. That's my sideways axis, so I find the 1. And then look, my output was 1 3800 centimeters, so I got to find that on my my y-axis. So at 1, I'm going to go up 1. Now look, I'm only labeling my units every whole centimeter, right? And then in between every half centimeter, there's no mark there. So we have to use that to estimate. So you guys can see I can see that this is 1.5, right? Okay. Now I got 1 and 3800ths, so that's more than halfway between 1 and 1.5. So I'm going to graph that right about here. Oops. Right about here. So we got 1 and 1.38, okay? And then for 2, we got 2, and that's almost 2 and 7500ths, right? Or 2 and 3/4. So at 2, here's 2. Here's 2.5. This would be about 2 and 7600ths. So 2, comma, 2 7600ths. Okay, and then for 3 hours, we have 3 horizontally, and we're going to find 4, and it's just a little bit more than 4. Okay, so that is at 3 hours, we have 4 and 1400ths. Okay, and then in 4 hours, we get 5, almost 5.5 exact. So at 4, we have 5 and 5.2. Okay? Now, if I was to draw a line through all this, here's what it would look like. And we have a linear function, right? And then because it goes to the origin, we didn't have to make an adjustment. It's both arithmetic, that my outputs are arithmetic and geometric, right? My outputs give me an arithmetic geometric sequence. That's if we're going by increments of 1. Because remember, first term, second term, third term, right? So if we skip or go halfway, that's my outputs not necessarily going to be a geometric arithmetic. Okay, so let's take a look. A bus travels 60 miles per hour. Write a graph and a rule to find numbers of miles the bus can travel in 4.5 hours. So now what we're going to do is we're going to use our graph to figure out, well, you know, this is what I have in the table. How can I estimate the values in between? Do you guys understand? So first of all, what is my function going to look like? What's my function? Who's got it? Alexis, what do you got? So we're having our function at x and what?
4.5.
No, that's what we want to know for when we enter x. So 60 what?
Miles per hour.
But remember, we have an algebraic expression, so we've got some variables in there. Right. So we're going to see that it's 60 times x. Okay, and we're not going to have to adjust this because if no time has passed, we haven't gone any distance. You guys understand? So again, this is going to go through the origin 0, 0. So if I am traveling in 0 hours, how far did I go? 0. In 1 hour, how far did I go? 60. In 2 hours, how far did I go? 120. In 3 hours, how far did I go? 180. In 4 hours, how far did I go? In 5 hours, how far did I go? 300. Very good. Okay, let's go ahead and graph this. So we saw that at 0, 0, okay? We saw at 1 hour, we have 60. We saw that at 2, we have 120. We saw at 3, we have 180. 4, we have 240. And then at 5 hours, we have 300. Okay, and we could use this graph to predict times in between. Okay, so what we want to figure out is 4.5 hours. Well, here's 4.5. Be right here, right? Because 2, 3, 4. This would be 5, right? Wouldn't this be 5 right here? So halfway, that's 4.5. So look right here. This would be 4.5 on my graph. 4.5 is my input. What's my output going to be? Well, we know that every mark in between is what? 30. So 240 plus 30 is 270. So 270. Okay. Here you go. All right. Okay. All right. Any questions? So you see how we can predict different outputs using the graph. Got it? Okay. Almost done. All right. What is the table of values? Who can tell me what the table of values is?
The Y.
Okay, good. You're talking about the Y, but what are the Y's? Outputs. Okay. So we're getting somewhere. Okay, so you said what? Yeah, so we're talking about the, a table of values talking about the inputs and the outputs, but what about it? What's been going on with these? Don't you see a pattern with these graphs? Yeah. Okay, now let me get you guys to understand this terminology because it will come up again. Not just in this class, but you will see it elsewhere. So the word I want you to think about is there's a relationship between the inputs and outputs. So here's what I need you guys to know for this example. It is a table of values showing the relationship between the inputs and outputs. Okay, now if you have your line is going up for every x you get and you increase, your y's increase, that's a positive relationship. You guys understand? If for every x you put in, your y's drop, that's a negative relationship. We're going to get to that later. Okay, does every relationship have an output of 0 for an input of 0? No, because remember, it doesn't always cross through 0, 0. So it's no, and I'll give you an example. Here's a function x, 2x minus 3. That doesn't work. You can see that if I put in 0, 2 times 0 minus 3 equals negative 3. That's not true. Okay? Let's graph the relationship represented by the table. So really quickly, I got 0, 5. So sideways 0, up 5. That's my first one. 0, 5. And then 1 and 8. So sideways 1. And then vertically 8. Here we go. 1, comma 8. And then sideways 2. Vertically 11. That's 2, comma 11. And then the last one, 3. And then 14. 3, comma 14. And so again, we have a linear relationship. And can somebody tell me what is the function that goes with this relationship?
It is 2, no, 3 plus, it's 3x plus 5. Yeah.
Hold on. What's the common difference?
3.
You see that it is increasing by 3 each time, right? So 3. And is that enough? Did it go through 0? No. Look at where it started.
Plus 5.
It crosses the y-axis at 5, so I need to put plus 5 right there.
Yep.
Okay, and does that work?
Yes.
Okay, that's it for my lesson. I will see you guys tomorrow. Tomorrow we have the quiz. Take the clipboard. Don't forget the clipboard.